The most important data type that we'll work with in Mathematica is a list. A list is the analog of a vector from MATLAB. So let me define a list called myList. And in MATLAB, I might have called it my_list, but we're never going to use underscores in variable names in Mathematica. Okay, we'll use them for some specific purpose later related to patterns. So instead, the way I tend to name things is start with a lowercase letter, just like we always do when we're defining things in Mathematica, and then start the next word if it's multiple words with a capital letter. So this is how I would write my list for a variable. And then equals, and then the way we make a list in Mathematica is with curly braces. So this is gotten by holding down Shift and hitting the square bracket button. And then I can have anything I want in a list. I can have 1, 2, 3, 4. Okay, so there's my list. Or I can also have a string inside of this. Strings are made by using double quotation marks. So some string goes here. So there's a new list. And if I want to get what's the fourth item in my list, I'm choosing that because that's the most interesting one, I use 2 square brackets. So when I was first learning Mathematica, one of my least favorite things was all the square brackets, and especially the fact that you need 2 of them. But eventually you get used to it. So my list double bracket 4. Okay, if I did my list double bracket 5, okay, then I get the 5th item in the list. If I want to know how long is the list, I get it by using the word length. So how should I type that? Yep, because it's a built-in function, I should type it with a capital letter. So length, and then I should use square brackets. It's a function. Functions in Mathematica use square brackets. So this is asking, what's the length of my list? Okay, and I get length 5. 1, 2, 3, 4, 5. And if you ever want to get help with one of these built-in functions like length, you put a question mark, and then you type in the name of the function. Okay, or if I want help with a built-in constant, like the constant e, okay, then it tells me what is this, and I can get more information by clicking on one of these double arrows, and then I get more information about it. So just like we made vectors in MATLAB using colon, there's a special way to make lists in Mathematica. So let me show it to you with an example. Say I do table, and let me do it the simplest way I know how to start. Table I, for I from 1 to 100. Okay, so I have table, then the whole thing is in square brackets. Then I have some expression, and then I have a comma, and then after the comma I have something called an iterator. In this case it's curly braces I 100. And let me evaluate it and see what it looks like by hitting Shift and then return. So what did this do? It made a length 100 list of the numbers 1, 2, 3 up to 100. And we got this using 2 numbers. Just like in MATLAB, where we used colon with 2 numbers, the default step size was 1. In Mathematica, if we use table with just 2 numbers, then the default step size is also 1. And if I want to specify a step size, like how about 5, then it's a little different from colon in MATLAB because the step size goes at the end rather than in the middle. But other than that, it's very similar. And it has the exact same rule of thumb as in MATLAB. It starts at the first number, it keeps going up by the step size, so up by 5 to 6, up by 5 to 11, and the rule of thumb is it's never going to go past 100, so it might hit 100 exactly, but it's never going to go past it, because that's what I've specified as this upper bound. If instead my upper bound was 101, and I evaluate it, then it also goes up to 101, hits it exactly. If my upper bound was 100 a bunch of 9s, then it doesn't go up to 101 because that's past this upper bound that I specified. And where we can see that this becomes more complicated than what MATLAB can do, at least using the colon command, is this I at the front. Only thing that was important was that it be the same as this I here. So let me just go back to 1 and 100 to make this part a little simpler. Okay, so here's the numbers 1, 2, 3, 4, up to 100. What if I replaced this I, what if I replaced it with a J? Okay, then what do I get? I get J, J, J for each possible value of I from 1 to 100. So I just get 100 J's. So you can think of this as kind of like a for loop, where it's for I from 1 to 100, put J into a list. And that's not that helpful. What if I wanted to do I squared? What would I get? Then I get 1 squared, 2 squared, 3 squared, all the way up to 10,000, which is 100 squared. Okay, the next one is going to be bigger, so let me change the upper bound to 10. What if I do 2 to the I? Then I get 2 to the 1, 2 to the 2, 2 to the 3, all the way up to 2 to the 10th. And something that we couldn't do in MATLAB, at least without installing some additional toolbox, is instead of 2 to the I, what if I have b to the I? And you can tell that b, it's not already been defined in Mathematica because it's in blue. Now I evaluate it. I get b to the first, b to the second, b to the third, all the way up to b to the 10th.